Okay, hi everybody. Welcome to 8th grade math. This is Module 1, Lesson 1. The title of this module is Integer Exponents and Scientific Notation. So we're going to be looking at writing expressions using exponents, and this is going to build upon what you've done in the past with positive exponents. We're going to expand that to integers, which can include negative numbers and 0. So, and we're going to apply that to scientific notation, which is just very useful, as you saw in the Powers of 10 video, if you've watched that one yet. So let's just get going and do a little review and move ahead. Okay, so if you've seen this, you're adding 5 3's together, and you saw years ago that you can write that as 5 times 3. So that's one way to use multiplication as repeated addition. Okay, so exponential notation is similar. So it's different in that I'm multiplying now. So if I have 3 times 3 times 3 times 3 times 3, 5 times, I can write that with a shortcut, 3 to the 5th power. So I've got 3 used as a factor 5 times, and I write that as 3 to the 5th. So when I want to just diagram this. So I've got this number down below, 3. We're going to call that the base, and to the 5th power. So that number 5 is the exponent. Okay. And the whole expression we call a power. Okay, so that's a power. 3 to the 5th is a power. The base is 3, the exponent is 5, and it means to use the base as a factor, whatever number the exponent is. Okay, so let's look at some examples. Here's some examples. They're not in your notes yet. We're not into your classwork yet. But we're going to work through these together. So in the first case, we've got 5 used as a factor. It looks like 5 times. So if I wanted to write that in exponential notation, then I would write my base of 5 and raise it to the power of 5. Okay. Since those are the same and I didn't actually mean for it to be the same, let's do one more. So what would 5 used as a factor 6 times be? Well, it would be that base of 5 to the power of 6. So 5 to the 6th power would be an equivalent expression and a much simpler kind of shorthand way of writing it. Okay, so now we've got 9/7 used as a factor 4 times in example 2. So I'm going to use 9/7 as my base, and this time I'm going to put parentheses around it and put it to the 4th power. And there's 9/7 to the 4th power. Okay, and now in this next expression, I've got the exponential notation already, and I'm going to write that out as what that means as an expression. So this one would be negative 4/11 times negative 4/11 times negative 4/11. So I used the base as a factor 3 times. And in this case, I used parentheses just to show that negative sign went with the fraction there. Okay, so in number 4, I've got negative 2 to the 6th power. So that would be this base of negative 2 used as a factor 6 times. 1, 2, 3, 4, 5, 6. Okay? So used as a factor 6 times. And then in the last case, 3.8 to the 4th. 3.8 is my base. So I can have a decimal number for a base like that, times 3.8 times 3.8 times 3.8. Okay, so let's look at these examples that we have here. So if you've noticed, sometimes I've used parentheses. So it looks like in 2, 3, and 4, I used parentheses. And down here I used them, although I didn't really need to. I just wanted to not let those decimal points get mixed up. Okay, so that's why I used them there. But let's talk about why we used parentheses in 2 and 3 and 4. Okay, so let's look at example 2 and talk about the use of parentheses there. So we had this expression, 9/7 used as a factor 4 times, and we wanted to write that in exponential notation. So I said we'll use parentheses and write it like that. And that means to use 9/7 as a factor 4 times. Okay, but what if I had written the expression like this without the parentheses? Think about what that might mean. And what it would mean would be to use 9 as a factor 4 times to make 9 the base, and then divide by 7, or to keep 7 as the denominator there. Because whatever is next to the exponent is what is used as the base. So if I want the whole 9/7 to be the base, which is what this expression is saying, then I need to have the parentheses around it. I can't write it like this, because this means use 9 as the base, and then, you know, do the fraction. So these clearly are not going to be the same product. All right, so parentheses are very important when a fraction is being used as the base. All right, let's look at another example. We'll just look at example 4, this one right here. And this one trips people up all the time. -2 to the 6th means use -2 as a factor 6 times. 4, I'm going to run out of room. Okay, -2. Okay, so use -2 as a factor 6 times. And that's what that is there. If I say, okay, -2 to the 6th power, what is this expression telling us to do? Well, just like in the last example where 9/7 was the base, in this example, it's saying to take the opposite and use 2 as a factor 6 times. 1, 2, 3, 4, 5, 6. Okay, so this is the exponential part, and the negative sign we'll deal with later. So -2 to the 6th is this expression. And in this case, these, as we'll see in a few minutes, we're going to do some more example, these will not be the same expression. They will have a different value. So if I want -2 to be my base, like this expression, if -2 is my base, I need to use parentheses around the base. Or the exponent is going to tell me to work on what's right next to it. Okay, so this would be 2 to the 6th and then take the negative of it. Okay, and that's just how we've decided to interpret these expressions. We've got to have some rules for it. So, okay, so let's move on. All right, so if I have, I'm going to start writing these expressions with an x, just x could stand for any number, right? So x to the 1st power is just x. It's x used as a factor 1 time. So we have x. X to the nth power, we're going to write like this, x times x times x times dot 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 x. And we're going to show that it's n times by writing it below like that. I don't know what that is, so I'm going to erase it. So let's see, what else? So there's some special powers. So x to the second power is also known as x squared. And the reason for that would be if we wanted to find the area of a square with side length x, we would do x times x. Same thing with x to the third power. It has a special name, x cubed, because if we want to find the volume of a cube, we could do that by multiplying x times x times x, or using x as a factor 3 times. So that would be, the example would be in a cube, like that. All right, so now I'm going to have you work on these exercises, exercises 1 through 10, and write the expression that they're asking for. So I want you to rewrite these in exponential notation. All right, so I'd like you to pause the video and work on that now. Okay, now go ahead and check your answers against those on the screen here. And I just want to point out a couple of them that you should have been aware of. So definitely parentheses are needed here wherever there's the fractions and the negatives. Here's a negative fraction. Definitely you're going to need parentheses around that. Whereas on this expression, 4 to the 7th, I didn't need parentheses, as I didn't on this one, x to the 185th. Parentheses around the negative here, and then these others you just had to put in how many times that base was used as a factor. Okay, so pause the video, check those, make sure you've got them correct before moving on. Okay, now exercises 11, 12, 13, and 14 all have to do with using negative numbers as a base. And I want you to go ahead and work on these on your own and come up with what you think the answers are, and then we'll go on and make sure to correct them together. Okay, so go ahead and exercises 11 to 14. You're using what you know about multiplying negative numbers to come up with some ideas about whether products will be positive or negative. And so you're looking for some patterns as well. And so let's see how you do with that. So go ahead and pause now and do exercises 11 through 14. All right, so in this exercise 11, you need to use this fact that hopefully you discovered last year and still remember. The negative 1 times negative 1 is a positive 1. Okay, there's a lot that goes into knowing and really understanding that, but negative 1 times negative 1 is positive 1. So if we look at this product, every time we have negative 1 times negative 1, that whole thing becomes just a positive 1. So we've got 6 pairs like that here. So when we multiply negative 1 12 times, we can always put together pairs of negative 1s, and those will always be positive 1s. So this product here, this first one is positive, and the second one, there's negative 1 is used as a factor 13 times down here. And so we can pair up the negative 1s up to a point, and then there's going to be 1, -1 left over. So this whole part will be +1. Then we'll go ahead and multiply it by the -1. And so this whole product will be negative. Okay. Okay, so an important part of this problem right here is this how do you know, okay? So hopefully you use some sort of explanation as to how you know. Either you calculated it or you thought of this idea of putting pairs of -1 and -1 together to get +1 and then multiplying those together to get +1. This idea that there's kind of one left over here. You might notice 12 and 13 are both positive numbers, but yet one of them had a positive result and one of them had a negative result when raising -1 to that power. So what is it about 12 and 13 that makes this one positive and this one negative? Okay, and so hopefully you maybe saw that it had to do with the fact that we could pair these up because 12 was an even number. And this had one left over because 13 is an odd number. Okay, now multiplying a bunch of ones together is easy, but multiplying 95 factors of 5 together could be pretty difficult. So you're asked, is it necessary to do all of those calculations to determine the sign of the product? Why or why not? Okay, so -5 to the 95th, right here, -5 to the 95th. So -5 uses a factor 95 times. Once again, I could think about this idea that -5 times a -5 is going to be +25. A negative times a negative there will give us a positive product. So looking at 95 factors, that means I have an odd number. That means I'm going to have pairs, a bunch of pairs, and then times a -5 in the end. Okay, so these will all be +25. So if I take all these positive numbers and multiply them by a negative number, this product's going to be negative. All right, so it was not necessary for me to multiply them all out, but I do know that whatever number it is, it's going to be a negative product. All right, and then let's look at the next one. I have a negative base, -1.8, used as a factor 122 times. This one is going to be positive because 122 is even. 122 is an even number, and so that means I can pair it. Whoops. I can pair them together and get all positive products, which is going to, in the end, turn out to be positive. So we've got a positive and a negative. All right, let's look at number 13. Fill in the blanks indicating whether the number is positive or negative. If n is a positive even number, then -55 to the n is it positive or negative? Well, if it's even, that means I can make those pairs. So this is going to be positive. And if the exponent is odd, that means I have one left over if I made pairs to get all those positive numbers. So it's going to make the whole product negative. All right, let's look at exercise 14. Josie says that -15 times -15 dot 6 times is -15 to the 6th. Is she correct? And how do you know? All right, I'm not going to write my answer. I'm just going to say it, but hopefully you have written yours and or typed it into Edpuzzle. So we said back earlier that if we want negative 15 to be the base, that we should write it like this, negative 15. We want parentheses around it to the 6th power. So the question is, are these two numbers here the same? Do they have the same value? And we'll think about it going back up to what we saw up here. If we have an even number for the exponent, then we're going to have a positive product. So here we have negative 15 to the 6th. 6 is an even number, so that means I can pair up these negatives. They're going to be positive. So this whole product here is positive. But the way this is written here, negative 15 to the 6th, this is the opposite of 15 times 15 times 15 6 times, right? Using 15 as a base 6 times. This here is a negative number. Okay, so this one right here is the opposite of a positive number, which means it's negative. So let me get my pen back. That number right there is negative. All right, so they are not the same, and Josie is not correct, and that's how we know. Okay, so that just shows you that it's really important to use those parentheses to show what you mean by your base. Okay, so here's just a reminder of that. You can write this in your notes somewhere. Use parentheses in expressions where the base is either negative, such as negative 2 raised to the 4th power, or is a fraction, 3/4 squared, or 3/4 to the 2nd power. Okay, so we need to use those parentheses to show what we mean by the base. All right. Okay, we've got time for one more example before you go to the exit ticket and the problem set. Okay, so I'm going to use this idea of half-life, and this is something we'll study in 8th grade science when we talk about elements on the periodic table that decay. Okay, so there's some elements that tend to decay, and so one thing that gets talked about is something called half-life, and the half-life of a substance just means, so if something has a half-life of 100 years, that means that half the substance decays every 100 years. So whatever I start with, after 100 years, I would have half of it. So I want to show you how this type of application leads to use of exponential notation. Okay, so if I start with 500 grams, after 100 years, I could write how much I have like this. I would have 1/2 of, or 1/2 times 500 grams after 100 years. Okay, so now what's going to happen in the next 100 years? So after 200 years, I would have 1/2 of the amount I had before. Let me use my pointer here. So I had this much after 100 years. So 1/2 of this amount here, I can write it as this expression. And then you get this after 300 years, I'm going to have half of what I had at 200 years. So I'm going to multiply by 1/2 again. So do you start seeing how this looks like exponential notation? So let's write those over here, over on the right-hand side. Okay, so at 100 years, I have 1/2 used as a factor once. At 200, used as a factor twice. So I could write that as, this would equal 1/2. I'm going to use parentheses because I have a fraction here. 1/2 squared times my starting mass. 1/2 squared times 500. And then at 300 years, another half-life, I have 1/2 to the 3rd power times 500 grams. So you can see when I get to many, many years. So what if I had, after, 1,500 years, I would have 1/2 used as a factor 15 times. And that would, my exponential notation would be a really nice shorthand. Okay, so then after n half-lives, so n being however many multiples of 100 years. Every 100 years, I get half the substance. So after n half-lives, I would have 1/2 to the n times whatever my starting mass is. That would be the amount of substance that I would have. Okay, so this exponential notation is really useful in this exponential decay, we call it. Okay, so we're going to have an example in our problem set very similar to this in lesson 2. So this is just kind of a intro to that. Okay, so I think you'll do okay. So do the exit ticket, make sure you correct it, and then move on to the problem set and make sure you get that corrected as well. We're going to try to correct work daily. That's going to be our goal this year. Correct your work daily, and I'll be able to see how you're doing by the answers you submit on these videos. So thanks for doing that, and I look forward to working with you guys. Okay, we'll see you back here tomorrow for lesson 2.